All right, section Q is on trig identities. I would say that trig identities do not show up a ton in calculus. You definitely do them in more depth in pre-calculus, but they still do show up a little bit. Okay, so the instructions, well, when we were doing them in pre-calc, we would have said prove that the two sides of an equation were equal to each other. In calculus, it would be more like you would recognize that the form of the equation is something that you can't work with. You need to take a derivative of it, or you need to do an integral of it or something. You can't work with it, you need to solve it, and so you would use an alternate form because that's something that in your previous math history you have learned is possible, and you recognize it's necessary for the problem. So that's kind of like the context of what we'll see in calculus. But in the summer assignment, I just have some problems for you to prove to help you practice getting back to that. So I'm not going to do a ton of examples here, but if you are really struggling with this section, you should go back and look at some of the videos that are more in depth in the pre-calc section of the website. All right, so the first equation we're going to prove is secant squared x plus 3 equals tangent squared x plus 4. And there are the identities printed in your packet on these pages, but also I have a resource page. It looks like this. I put a link up on the summer assignment page, so if you want to print this out, that's the Trig Identities resource page, then you can just have all the identities right in front of you. So whenever I'm looking at a problem that has something squared in it, I'm typically going to be looking right here because those are the Pythagorean identities, and so these are the best exchanges back and forth between things to just like make my life a little bit easier. So if I'm solving this equation for number 1, and actually, nope, just solving it. I'm looking at the first one. I can see that the relationship on the page is between tangent squared and secant squared, and I can see that secant squared is the same as 1 plus tangent squared. So I'm going to do a substitution on the left side. I'm going to say that secant squared is the same as 1 plus tangent squared. And then 1 plus 3 is 4. And so that's done. That's all I needed. So a lot of times the things that you're using in calculus when you're using the trig identities, a lot of times they're not overly complicated like they were in pre-calc. It really is just changing one little thing so that you can work with it. All right, the next one we're going to look at is that sine squared x equals 1 minus cos 2x over 2. Okay, so here on my page, if I'm looking at the Pythagorean identities, the Pythagorean identity says sine squared equals 1 minus cos squared. And so I know that substituting that for the left side is not beneficial. That means that what I'm going to do for this problem is I'm going to look at the cos 2x, and I'm going to see what substitution to use there. And if you look at this page, you've got lots of options there. So cos 2x has all 3 of these. So if I'm thinking this through, I want to use the one that's going to get me a direct relationship back to sine squared. It's not this one because this one has a cos squared in it, so that's going to have 2 different pieces. That's going to be a little bit harder to work with. Don't use this one because it's not helpful at all, but I'm going to use the last one. So I'm going to replace cos 2x with 1 minus 2 sine squared. So I'm going to have 1 minus, and then in parentheses, 1 minus 2 sine squared x. And then that's all being divided by 2. So I'm subtracting those parentheses. That means I can distribute the negative. So I've got 1 minus 1 plus 2 sine squared x. And so the 1's cancel. 1 minus 1 is 0. And then I have 2 sine squared over 2, and then the 2's cancel. And so I'm just left with sine squared equals sine squared. And this is actually a specific identity on its own. It's just not one that we study in pre-calculus. So I'm going to have you add that to your resource page if you printed it. If not, add it to your summer assignment packet. This is called a power reducing. So the power reducing identity is that if you have sine squared and you don't want to have a squared, you don't want to have an exponent of 2, then you can replace any sine squared that you see with 1 minus cos 2x divided by 2. Because there will be a point in calculus when it's easier to deal with a 2x on the inside than it is to deal with the squared on the outside. Okay, the next one that we're going to look at is actually basically the exact same problem. It's just the power reducing formula for cos squared instead. So for this one, we're going to say that cos squared equals 1 plus cos 2x divided by 2. And then we're looking at the same portion of our identity sheet. Again, cos 2x. This time, instead of using the third one, I'm going to use this one because this is the one that has the cos squared in it. So I'm going to say 1 plus, and then it was 2 cos squared minus 1. And again, the ones cancel. A 1 and a negative 1 makes 0. And then 2 divided by 2, those cancel, those make a 1. And so I've got cos squared 2x. That wasn't 2x, that was just x. My bad. Gotta be paying attention. So when I did the replacement, I accidentally wrote 2x, but I meant just x because it's a power reducing. So it wouldn't have, in this case, I power increased. I'm going to stop talking now. All right, so on my sheet, I'm going to add cos 2x is 1 plus cos 2x over 2. That's the second power reducing formula. There are probably others, but honestly, these are the only two that really get used.